Hey guys, just thought I'd make a quick video showing how to take algorithms from the algorithms for a decision making book and transfer them into a format that you can use for homework 3. So let's look down at this Monte Carlo tree search algorithm. So you've got this kind of outer loop function, this structure, and then the simulate function with an exclamation point. So I'm going to show you how to adjust sparse sampling, and you can do kind of the same thing for the MCTS algorithm. So the first thing is this struct here, and they kind of have that for all of their algorithms just to hold all of the parameters. But for you, these are either going to be given as arguments, or you can just hard code them into your code. So you can really get rid of this part. But take into account, maybe keep track of, what these different elements of it are. So then this function, which is which makes objects of type sparse sampling callable, this is actually going to turn into your select action function. So this is going to take in a MDP object and a state, and then return something, return an action. So we can get rid of this pi structure here, but everywhere we see this fancy p, we're going to actually replace it with our problem definition, which is m. So I'll replace that with m. I'll replace the depth with some depth, we'll say 10. This pi of m is the number of samples, so I'll change that to C, just so that we have we're not overwriting the m. Let me change that. Okay, so actually I have to make a number for this, so I'll just say that's 10. And then this pi.u is like our estimate of the values, so we're not going to pass that in as an argument. We're just going to keep that and hard code it in here. So the first thing I'm going to do is I'm going to get rid of all of these p's because they're hard to type. Okay, so something like this. Everywhere we see a p, that's the problem definition, so we replace it with m. Now let's see, what do we need to do? So this p.a is the action space, so we can replace this with actions of m. I'm just going to go in line by line. So this terminal value estimate here, we actually want to replace that with a rollout policy. So we might do something like p equals function policy and we pass in a little function like this. This is the stabby function syntax, which you can look up in the Julia documentation. And this will just be like rand actions m. So this is a random rollout policy. And then we can feed that into a simulator and get this little u. So we can say simulate rollout simulator. And you'll have to import this from the appropriate package, but that's in the starter code. Something like this, mps. I think that's right, but you can see that in the starter code. Then replace this with the value estimate that you get from that rollout estimate. Everything else looks like it's kind of been replaced. So this rand step is going to be replaced by at gen. I think it looks like something like this. And then sparse sampling is just that recursive call, so that should look exactly the same, except we got rid of this u argument. This p.gamma is the discount factor, so we can replace that with discount of m. And that looks like it. So that's basically the way we adopt these an algorithm like this for homework 3. The first step is replace this function with select action, and then the second step is basically go through and replace all of the calls to that fancy P with all of the palmdps.jl calls. So hopefully that gets you started if you're stuck.